Hello and welcome to the presentation Big Data, Still Needed, Still Useful. The concept of big data was born more than 10 years ago, and I still remember these first days. Big data was very broadly discussed in the tech industry. Many customers, many companies were thinking, should we collect more data? How can we leverage the data that we have? How can we do that in the most efficient way? However, now we are here in year 2023, and the question is big data still needed? The idea for this presentation came when I stumbled upon an article by Jordan Tigani, a former Google engineer, so competition. Jordan used to work with Google customers and with Google data and big data technology, and he reflects upon whether big data is still needed, coming to the conclusion already visible in the title: big data is dead. Big data is not needed anymore. He claims that this is for several reasons. One, most companies don't have that much data. Most companies have less than 1 terabyte data, which isn't huge in terms of big data. Even if some companies do have more data, there is a strong storage bias, meaning a lot of data is stored, but just small percent of it is actually used, is actually processed, transformed, queried. And normally, this is the most recent data. Also, the technology advanced quite a bit in the last years, and the data amount, the data format that we would previously need advanced technologies, specialized big technologies for, can currently be transformed, processed using simpler technologies and compute power. The article is very interesting, and I found it exciting given my own experiences with companies that work with big data and the challenges that they are facing. Hence this presentation, during which I will be discussing the ongoing business trends related to big data, but also how Microsoft technology, how Azure addresses them. I will also address the challenges that I've observed when using these technologies and how to deal with them. The presentation doesn't have the ambition of being a systematic review of these technologies and use cases. It should present the most salient cases and give you something to think about. My name is Agnieszka Niezgoda. I'm a senior data and AI solution architect, and I normally work with partner channel in Central Europe. You have my contact data here. But before we go on to discuss the trends, let us spend the next 2 minutes on defining big data. Big data is normally defined by reference to 5 or even 7 V's. Here I compromised and I included 6 V's. But the general consensus here is that it's about considerable amount of data, and it's about data that is unstructured or semi-structured. Or, to put it differently, big data is data that can hardly be transformed, worked with, using the traditional relational databases. It can hardly be worked on using traditional databases because it's too large, because it's too unstructured, and because it frequently contains real-time data. So a lot of data coming in real time, streaming data. Use cases with which SQL databases don't deal that well. despite the advances in the last years. There are four typical workloads here. Batch processing, real-time processing. This can be done in one process in terms of architecture, so Kappa architecture, or it can use different processes, different transformation paths for the data. Then we have interactive exploration of big data. In Azure, you can use Synapse for that, ADX in Synapse, for example, but that's not the only option. And then this use case, this workload that has been getting more and more attention, of course, predictive analytics, machine learning, which we will also address during this presentation. Okay, so without further ado, let us discuss the first big data trend. The first trend that I want to discuss is that of the lakehouse. Lakehouse is a term that has been coined by Databricks, I believe. And indeed, Databricks is the best example of a lakehouse. However, it's not the only one. So Synapse, for example, has much of the functionalities of the lakehouse and can be considered a lakehouse solution too. The lakehouse is a kind of a crossover, a kind of a hybrid approach between a data warehouse and data lake, which simplifies dealing with data. So just a few years ago, we used to have data warehouses and data lake. Data warehouses were mainly used by data analysts who used SQL to transform data and to query them. Data warehouses collect structured data. We are talking about SQL databases. So it's about structured data in the form of tables. And data warehouses also have some quite cool features, such as it's very easy to understand what happened to data, how it was transformed, and everything is ordered in a logical structure. However, as we started to work with more and more data in different formats, also with semi-structured, unstructured data, such as South files, pictures, etc. Data warehouses simply weren't enough, and even with advances in data warehousing technologies such as MPPs, which enable to store large data amounts, it wasn't enough simply because it focused mainly on structured data and didn't make place for unstructured data. So hence, we also had data lakes. Data lakes used mainly by data scientists, by machine learning engineers who needed to access the data, defined schema on read. Here, the challenges were mainly one, the amount of data, which was quite considerable, and then also the chaos. What I mean here is that it's difficult to catalog, it's difficult to classify the data that you store in data lakes, and which sometimes led to the data lakes being kind of a dump for everything. When it comes to this first challenge I mentioned, data amount, Hadoop addressed that. Hadoop, which had advantages, it was able to deal with a lot of data in a quite efficient way. However, it still had some drawbacks, like some overhead in data processing. They need to materialize data between longer operations, and also they need to chain operations, chain jobs, instead of creating one longer job that could be then optimized. This is where Spark comes in. Spark and the idea of the data lakehouse. Data lakehouse is, as I said, a hybrid approach that uses the advantages of both data warehouses and data lakes. It can be used with both SQL, but also with other languages, with Python, with Scala. It creates a schema which allows you to apply it to unstructured data. The schema is created by a layer of metadata, which includes information that is very helpful when dealing with this data, for example, which makes it possible also to see the history of the data set of the table that you work with. One interesting feature here is the separation between storage and compute. I said at the beginning of this presentation that this is something that can be observed. Companies have a lot of data, they store a lot of data, but they don't work with most of it. Some of it is stored for compliance purposes, for reporting purposes, and just lays there. It needs to be there. At the same time, it is important to have a process that deals with spikes in the demand for compute. For example, let's imagine that we have financial data, and the finance department tends to work with the data mostly during month closures and year closures. So at that time, we need a lot of compute, but apart from that, the data is simply there and we shouldn't have to pay for compute. So this is what the lakehouse makes possible. Apart from that, the lakehouse runs on Spark in the Databricks case. So it is simply very performant. It makes it possible to use the power of parallelization, so several workers which are assigned the role to conduct certain jobs, to conduct certain tasks, and to deliver back the result of the jobs in order to speed up the whole process. The data format which is preferred in the lakehouse is the Delta, which also offers quite cool advantages. It's an open format. It's not proprietary, which means that you can use it in different tools. If you don't like Databricks, for example, if you discover at some point that it's not what you looked for, you can move your notebooks to Synapse and it will work after you created clusters there, of course. The Delta format, in a few words, it's a format which has additional metadata, including transaction logs. It makes snapshots of your data, and then it also stores the difference between the delta log, basically, between the versions. This makes it very performant. The files aren't huge, but if you want to read them, it's much faster than reading CSVs, not to mention JSON files. What it also makes possible is this feature of time travel. So if you discover that you transformed your data into something it shouldn't be, that you committed a mistake, it's not a problem because the versions are stored. So you can move back to the previous version or to the versions from a specific point of time in the past. It also makes it possible to deal easily with schema evolution. Schema evolution is one of these points data engineers aren't happy about, of course, because it's always a challenge to adjust to. However, the Delta format offers even to automate it if you want it. Of course, it also supports merge, update, and delete operations. It sounds great, and it is great in many respects. However, when working with partners and customers who work with the lakehouse, and there are many because of the cool advantages that I talked about, we are sometimes facing challenges, especially in respect to two main aspects. The first one is cost. It's important to establish good governance practices and to monitor costs when working with Databricks. Spark isn't cheap. However, the cost can be controlled. So by creating good access policies, by controlling who can create clusters and what type of clusters this can be, you are reducing the probability that something will go wrong and that you will lose money unnecessarily. Also, leveraging such features like auto shutdown, like auto scalability is important. You can track this cost very easily in the Azure portal. You can see even which jobs cost you how much, which is a very cool feature, I think. However, you have to set it up, you have to remember about it. Then performance. Databricks is a SaaS. It looks very easy to use, and it is in many respects. However, this can sometimes be misleading because a lot of code will work, but it will cost you, for example, more if the code isn't adjusted, if the code doesn't reflect the best Spark practices. So although Databricks and the lakehouse is not a super new technology anymore, although there are quite a lot of engineers on the job market who can work with that, many of them can work with Databricks and Spark on a quite superficial level without knowing what is behind the visible and without knowing how to optimize that. That, however, might be important in order to avoid writing code and running code in a way that isn't efficient and which will cost you more than it could cost you. The next trend that I would like to discuss is one of governance and data privacy. Here in Europe, when we think about data privacy legislation, we mostly think about GDPR, of course, RODO in Polish. However, it's not just that. Elsewhere in the world, there's other legislation, for example, CCPA in the States. But Gartner says that by the current year, by 2023, 65% of the world's population will be covered under modern privacy regulations. So quite a lot. It's normally not about all data. It's about personally identifiable information, about data that refers to people, to existing people, such as names, addresses. In Poland, we have PESEL numbers, etc. However, the regulations do give those people whose data you store quite few rights. They have the right to not to be okay with you storing the data or withdraw the consent, even if they granted it before. And this has very important consequences when it comes to how we work with big data that includes PII in Azure. Previously, I talked about Databricks, so let me start with Databricks also here. Databricks launched a Unity catalog a few months ago. a Unity catalog, which is a way to govern workspaces, which basically adds a higher level, one additional layer of control over workspaces. It is free in the premium version of Databricks, and it gives you the power to decide who should have access to your Databricks workspaces, but also data assets in the workspaces. It also makes it possible for data to be shared across workspaces in order not to reinvent the wheel and create the same thing, the same catalogs in workspaces whenever this is needed. It gives you also a place, a way to govern accesses, users and groups centrally in Unity catalog instead of having to do that individually in each workspace independently. In the Unity catalog, you work with so-called meta stores. So you create meta stores and then set them up. After you've done that, you also have quite a bit of information, including permissions information on your data products, which you can access in the Data Explorer directly in workspaces. Here you can also define access to individual tables, to individual schemas. It offers quite a bit of additional information, including lineage. So you can see how specific table is used, which pipelines, dashboards, queries, etc. use a specific table. And this is, as I say, very, very important, because if you use PII in your data set, in your table, and then you discover that the person whose data you included in your table withdrew his or her permission for you to deal with the data, you can see immediately how the data is used, in which notebooks, in which queries, in which dashboards, and you can act appropriately to correct that and to delete, to remove this data from every place in order to be compliant with the legislation. But of course, it's not just about granting accesses and lineage. It's also about finding out if some violation of policies took place. And here, Defender is a very valuable asset to have. For example, let's assume that you have a lot of data in Power BI dashboards, and you would like to be notified if somebody downloads too much data, because it may mean that the person is a rogue actor and you will be breaking the law if the person steals your data. You can monitor what is happening in your Power BI here in Defender, down to the level of monitoring if somebody takes screenshots. I conducted an experiment. I wanted to know if Defender will find out that I made a screenshot, and actually it did. Of course, you can also use notifications here, alerts, so you can be notified every time violation happens. The third trend is linked to the previous one quite strongly, and it's about DevOps-like approach to data. So data ops, ML ops. Data ops is a lifecycle approach to data analytics. It's like DevOps for data. So like DevOps, it's about agile practices to orchestrate tools, but also code, infrastructure, It's about building the correct culture in order to deliver high quality data products. And there are some best practices when it comes to data ops. You will find that on Microsoft sites. I included a link in my presentation. Here, just to give you a few examples. You can label sensitive data in Azure manually or in an automated way. Manually by creating so-called sensitivity labels. Some of them are included once you create your tenant, but if you need some other ones, you can create them. But also in an automated way by classification in Purview or by using data loss protection labels. Here in the screenshot, we see that it was discovered that dashboard uses credit cards details, and this is labeled appropriately. But of course, this is even more developed in Purview. In our Microsoft data governance solution, Purview gives you a full picture of your data. It gives you a full picture of what you have, and also labels, classifies those data assets that highly probably includes PII. You can adjust it to your needs, of course. You can select which PIIs should be labeled, should be pointed out, and which you aren't interested in. MLOps is a similar approach, which is used for machine learning efforts. So it provides you the visibility on what you've been working on, and transparency on everything you did. So it makes it possible for you to reuse the models, reuse the data, and to have full transparency on, for example, the parameters, the setup of the experiments that you conducted. I could talk here about Databricks. Databricks does MLOps quite well. However, in terms of MLOps, Azure Machine Learning is absolutely masterclass, in my opinion. Here you see a screenshot from Azure Machine Learning from AML. And what you see listed on the left-hand side, data, jobs, components, environments, models, endpoints. These are the things that are documented here. So you have the versions of your data, the versions of your pipelines, etc., all documented. You can refer to them. When it comes to data, you have the source of the data documented, the schema, sample data. When it comes to jobs, you know whether they failed or were successful, and which parameters you used. Environments are therefore there so that you don't need to create a new environment every time you deploy, for example, a service, a model. So you have components, you have elements which are reusable here. Reusability is a key word in this case. And of course, endpoints, you can observe what has been functioning, how well, how many efforts to reach the endpoint failed, and similar statistics. You can also get notified about the elements of the process when something fails. I'll give you an example. Big data visualization is also a trend. Several years ago, nobody would think about visualizing huge data amounts. This distinction between OLTP systems and OLAP systems was a part of theory everybody knew about. And currently, when I work with partners, I frequently receive questions about the huge data amount that they want to get into Power BI. I recently had one partner that came to me and they said that they wanted to display everything from the SAP operational transactional database in Power BI. This is something new, as I say, which was obviously impossible before. The good news is that Power BI has developed really a lot in the last years. And the screenshot that you see here portrays that a bit. The limits for the size of the dataset, for example, are currently very high, or to put it differently, they can be very high. But of course, the more data you need, the more you have to pay for that. And this cost element is a very important consideration here. If you want to display everything from your transactional data system in Power BI, it will cost you quite a bit. So it probably makes sense to discuss it with business and to consider together whether it makes sense, whether this is really needed, or maybe you could leverage several different tools for different purposes, not just Power BI. Also to keep in mind here are the performance considerations. So, for example, Synapse has some limit on concurrent queries. If you will have 100 users in Power BI working with your dashboard or report at the same time, this is important to know, this is important to consider, because Synapse might say, no, sorry, this is too much, I won't provide you this data, at least not simultaneously. Some other data stores don't have such a limit, but the limit is implied, meaning that the performance of the data stores will deteriorate as the number of queries that reach the stores increases. So this is also something to remember. So what should you do if you still want to have a huge data amount visualized in Power BI? The first thing is think twice if this is really needed. Or maybe you could leverage some other tools like Synapse Analytics for analysts to work with and get a bit smaller amount of data into Power BI. Then pre-aggregate the data. You can pre-aggregate the data in your data stores, for example, databases in the storage account, if you connect Power BI to the storage account. However, if you are using Power BI Premium, it also has some AAS, Azure Analysis Services functionalities now. So you can leverage that by building models there. What is quite important aspect is that the import mode normally works better than the direct query modes. You might also want to experiment with the composite model, meaning that the data that is not queried that frequently in Power BI should be defined as the direct query connection, and the data that is needed for the report to function and which is essential and queried a lot should be an import. And there are some additional functionalities, especially in Power BI Premium, that can make it also easier to work with huge data amounts. One of them is the large dataset format, which can be switched on. The incremental refresh, but also so-called automated aggregations. So on the basis of AI models, Power BI decides itself what aggregates make sense and create them for you. Another trend that I would like to discuss is the low-code big data processing. And also here, let us start with Databricks. Databricks launched a so-called Delta Life tables a few months ago, which is basically such a low-code solution. It includes also so-called autoloader to process especially streaming data that should be processed immediately after it lands in your storage account. And it looks like this. So a very visual way of presenting what is happening in your data engineering pipeline. You see different tables, different views. Two modes are possible, the batch and streaming modes. You have all the information about the whole pipeline here. However, the pipeline itself and the tables that are created here are created in notebooks. These notebooks are, however, written very easily. This is a very declarative way of working with Python. This library which is needed to run that DLT is very intuitive to use. I would dare say that even to use by people who aren't data engineers. A cool thing here is that Delta Life tables include a very easy way to create data quality checks. Data quality checks are called expectations in Delta Life tables, and they are defined here by the penultimate box here in the slides. So you see it's very intuitive to create a thing like that. And then you see the results of your data quality check directly in Databricks, where you see the whole pipeline. Databricks is not the only solution that included this very visual, very low-code way of creating data engineering pipelines. Azure ML is another one. It has this component called Designer, and you see that there are several boxes here linked to each other, and they can be configured simply by clicking on them. You submit, for example, parameters there. Of course, also in Synapse you have that in Synapse pipelines. So this low-code, this visual way of processing big data, of course, has advantages. The advantages are it's easy to understand, it's intuitive. However, I like to think about it as a way of as a form of a scale, basically. It obviously has some trade-offs. Using the example of Databricks, on the one hand, you can work directly in notebooks on the level of code, and everything is possible. Everything what can be written in Python can be written also in Databricks notebooks. On the other hand, you have Delta Life tables. You have Delta Life tables with autoloader, which make it possible for you to create the pipelines very easily. However, if you want to do something which is not very typical, you want to create some Spark optimizations. You want your data to be processed differently than the standard way defined in the low-code tools. This might be more tricky. By the way, I didn't mention that Delta life tables have this predefined way of optimizing your code. Basically, if you are using Delta life tables, your pipelines will be optimized automatically. You can switch this functionality off. You have also a few things, a few settings that you can change. For example, when the cluster is switched off. However, there are not so many of them. And the last thing I would like to discuss is serverless in data engineering. So we could think that serverless is something supernatural when it comes to cloud, because it reflects basically the inherent advantage of cloud. You pay for what you need, and you don't have to you don't have to pay for things that are useless. You can simply switch them off. However, when it comes to big data engineering, this is not so self-explanatory, because for some time, clusters or VMs that you didn't use had to be also switched off manually, or you had to turn on a setting that switched it off for you after, for example, a predefined number of minutes. Or you could also leverage CI/CD tools to switch them off, or automation scripts. However, now serverless is coming. It's coming also to Databricks. It exists already for data warehouses on Databricks, but I know from Databricks colleagues that they are planning to launch it also in the other capabilities on Databricks. This is, of course, good news, also because it means that this cold startup at the beginning, when you need a few minutes for clusters, for example, to start and to be operational, won't be there anymore. Hopefully it will go down, or the time needed for that, the duration will go down, or it won't be there at all. Great news for all of us, and here I don't see that many challenges. To summarize, let me say that we see an overall trend towards simplification. So, for example, we see that customers want to have one lakehouse instead of warehouses and data lakes, that they want to be able to use low code instead of coding. And the second trend that we see is the trend towards more control and risk reduction. So in terms of data privacy, in terms of data ops, ML ops, we want to have control over our data, but also over our processes, and we want to be able to reuse what we've already done. But the general rule here remains, don't replace processes with technology. I used to have this boss years ago, whose favorite saying was, we don't digitize stupid processes. Stupid processes turn into stupid technology. And I think she was right. So if you think that you would like to now visualize your whole SAP transactional database in Power BI, or you would like to have Spark clusters in Databricks run the whole time, the question to ask yourself is why? And the cooperation, the exchange between business and IT is very important here, because Azure offers a lot in terms of big data. It offers you choice also to select solutions that suit your needs, but you have to know your needs, and you have to be able to balance what you get versus the cost, because everything is possible, but not everything has the ROI that justifies using it. Thank you a lot for your attention.